Through the years, air pollution has been one of the main climate change factors due to its large composition of greenhouse particles that affect the atmosphere and the human health. Air pollution in Nuevo León is considered a critical issue due to its high amount of particles in different areas of the state, contributing severely to the atmosphere pollution. We have some gases that are responsible for the air pollution. One of the most popular is the carbon dioxide. Nevertheless, it is not the most dangerous particle. Instead, we have the methane that affects the atmosphere due to its composition and its effects inside of it. The production of these gases is due to activities as agriculture and livestock that are the most extensive and dangerous activities done throughout the state of Nuevo León. According to the last information, if methane gas is still produced in high quantities, the air pollution will be increased.
A cell membrane that divides methane into a renewable source. Documentary research based on agronomy with results that ensure a cleaner location.
The main goal of the project is to reduce the levels of methane gas emission in the livestock sector within Apodaca, Nuevo León, through the implementation of biogenerators to store the biological waste of the animals, filter the gas to the plasma membranes made of the SVN zeolites that can capture methane gas and transform it into pure methane gas, and finally transform the particles into biogas energy within the Apodaca sector.
The first term you have to familiar with is the methane gas. This because it is the main factor in which our investigation is based on. Methane is a chemical compound with the simplest alkane and the main component of natural gas and called same gases. It is one of the several gases including carbon dioxide, nitrous oxide, and fluorinated that are greenhouse gases. These pollutants trap heat in the Earth's atmosphere, which ultimately leads to the global climate change. The state of Nuevo León created in 2010 a program called Programa de Acción ante el Cambio Climático para el Estado de Nuevo León that was planning to last 5 years. This program consists in applying many plans and strategies. One of the more important was the mitigation strategy that serves to stabilize the emissions and concentration of gases that originate climate change.
Well, but what is a plasmatic membrane? Let's talk to it. The plasmatic membrane can be defined as selective barriers between two components through which selective transport can occur. The separation of absorption of gases in membranes is possible due to the difference in the rate of movement of the different species through that membrane. For membranes having large pore sizes of 0.1 to 10 micrometers, the gases penetrate via convective flow and there is not much separation of the gases observed because flow depends on the viscosity of the gases. Membranes used for gas separations can be generally classified into organic polymeric in membranes and inorganic membranes.
It can understand a biodigester as a natural system that takes advantage of anaerobic digestion, in absence of oxygen, of the bacteria that already inhabit manure, or other organic ways to transform them into biogas and fertilizer. Nuevo León has opted for clean energy and the use of biodigesters since 1993, but in recent years more municipalities have joined in this initiative. Clear examples of places with the use of biodigesters are Granja Avícola La Curva in Bustamante, where a biodigester and a photovoltaic systems operate, as well as the spa Las Margaritas Peak facilities, which has a 65 kilowatts wind turbine.
Zeolite is one of the main components of the project because of its main purpose inside the protocol. The first zeolite was first discovered in 1976 by the Swedish mineralogist Cronstedt, said Flanagan, Roach and Wilson, 2017. Cellulites were used since they were discovered. This material in its natural or in its synthetic form is capable to perform different activities in the industrial field. All cellulites have a single characteristic. They are able to absorb any of the particle gases, like methane, ethane, and propane. They are commonly used in the industrial field because of its absorption of molecules. Indeed, Peña in 2017 concluded that the SBN cellulite is able to perform different activities of absorption of molecules. The SBN cellulite can absorb high quantities of methane in a low period of time, said Peña in 2017.
Biogas energy is one of the most useful renewable energies in the livestock sector. According to Zucker et al. 2010, biogas is a mixture of methane, carbon dioxide, water, and hydrogen sulfide produced during anaerobic decomposition of organic matter. Biogas energy was first discovered by Alexander Volta in 1776, according to Fluid Biogas Energy 2005. Renewable energies use abiotic factors to transform them into energy. An example is biogas energy. Biogas energy uses polluting gases that affect the atmosphere to transform them into energy. Methane is the most useful gas for this type of renewable energy. Pure methane takes 70% of the total mixture to obtain biogas energy, said Zucker et al. 2010. Biogas energy is commonly used in some states of Mexico. Nuevo León is the state that has the most biogas plants in Mexico. According to Garcia 2014, from 2003 to March 2014, the entity of Nuevo León had a saving of more than 157,396,000 pesos by generating electricity from biogas extracted from garbage. Nuevo León has different biogas plants, commonly using methane and carbon dioxide that waste emits to make the transformation of gases into energy. Actually, the state of Nuevo León is still doing this activity. According to the biogas company Gasum 2019, the biogas energy is obtained by biowaste. It is crushed into smaller pieces and suspended to prepare it for the anaerobic digestion process. Slurring means adding liquid to the biological waste to make it easier to process. Since the microbes need warm conditions, so the biological waste is heated to around 37 degrees Celsius. Next, the actual biogas production is done by anaerobic digestion in large tanks for approximately 3 weeks. In the final stage, the gas is purified or improved by removing impurities and carbon dioxide.
Now we are going to talk about livestock in Nuevo León. According to Jose Francisco Lopez, creator of economic schools and recognized by his website Economipedia, livestock is defined as a part of the primary sector whose economic activity consists of breeding, domestication, and exploitation for production purposes. Livestock has as its ultimate goal the production or procurement of goods. Production or procurement of goods whether for food purposes or not. For example, eggs, milk, or meat are food goods. However, the wool of a sheep is intended to serve as raw material for the production of clothing. The biological process which, through the feces of cows, generates methane is known as enteric fermentation. The United Nations Food and Agriculture Organization understands this process as enteric fermentation refers to the methane that is generated during the digestion of ruminants and monogastrics, although in these the levels are much lower. The quality of the food is very closely related to the enteric emissions. For example, diets with a high proportion of high fiber ingredients are related to higher enteric emissions. The radius of growth, accompanied together with the support of different investors and the UANL, the latter being an important boost to the local livestock that classify a possible large industry to Nuevo León. As Carla Suarez Flores, president of the Mexican Meat Council, mentions, we have been growing slowly in the last 2 years. Nuevo León contributes big to the meat industry. In 2017, it contributed 17% of almost 2 million tons of meat, and in Fahrenheit Colin contribute 7.5%. Nuevo León has been recognized as a potential meat inductor, as it has a favorable increase year by year. Around 600,000 cows per year are fattened in the entity, a sector that represents an opportunity for growth, according to Virgilio Bucio Reta, delegate of Zagarpa in Nuevo León.
Cattle fattening are weaned calves that have been raised for certain weight and are then sent to fattening pens, also called feedlots. In these pens they gain weight before being slaughtered, and on average 3 or 4 months are required to gain weight from an initial weight of 600 to 800 pounds for the desired final weight of 1,000 to 1,300 pounds. More than 90% of the cattle of the state are produced in Apodaca, accompanied of the municipalities of Anáhuac and Montemorelos. The predominant production system is that of extensive agostadero, which makes these three predominate in fattening cattle. As for induced grasslands, there are approximately 500,000 hectares of timelines in induced grasslands where buffalo grass predominates. Additionally, there are about 20,000 hectares of grasslands with irrigation systems with African starter grasses and Bermuda crosses, in addition to about 150,000 hectares of forage crops such as sorghum, corn, oats, pastures, and alfalfa.
In this part, we select the SBN zeolite based on its characteristics and properties, and the place where we want to carry out the process, Apodaca, based on the environmental factors and considering the economic and livestock sectors. Then we release that for have a greater absorption and therefore a greater production of energy, we must collect the residues of the cows and through a system of tubes conduct the methane to the membranes and later transform it into energy by the biogas process. To be able to find additional information, we can look in the reference and bibliography of the sites and documents we use for take the information we need before. Finally, we added the information and write it down on a document explaining the processes we must follow and the specifications of the solution we have in mind.
Hypothesis 1. The implementation of the plasmatic membrane made of SBN zeolites in the livestock sector of Apodaca will transform high quantities of methane gas into pure methane gas. Hypothesis 2. The pure methane gas can be transformed in biogas energy. The capture and the transformation of the particles into biogas energy will reduce the levels of methane particles in the livestock sector inside Apodaca, Nuevo León.
The independent variable is the functioning of the plasma membranes and the zeolites on which they are based, since they can capture methane regardless of the conditions of the place where they are found and the levels of pollution. The dependent variable is the amount of methane gas transformed into pure methane, since they are directly affected by the functioning of plasma membranes. The independent variable is the biogenerator and the methane gas transformed by it. The dependent variable is the biogas produced, since the energy increases or decreases according to the amount of methane transformed. The independent variable is the transformation of the particles into biogas energy. The dependent variable is the level of methane particles in the livestock sector of Apolaca. If this transformation is high, then the level of methane particles will be reduced. The control variable in all the hypotheses is the natural environment without the membranes, in which the conditions are normal and the emissions are not altered.
In the results of the first hypothesis, we have four graphs. In the linear, there is an increase in the separation factor of CH4 and CO2 with the zeolite membrane in the increase of the pressure drop. The second described diffusion of CO2 and CH4 inside DDR pores and suggested that DDR membranes are favorable for CO2 and CH4 separations. The third graph is observed favorable absorption of CO2 and C2 hydrocarbons with respect to CH4 suggests that this material can separate CH4 of mixtures of CO2, C1 and C2, and in the last was found to show good ability to separate CH4 of 100 purity from these CH4 mixtures. Therefore, the zeolites in the membranes we will implementate will separate the CH4 from the mixtures and transform it into pure methane gas.
According to the following graph, methane, CH4, has more percentage in the total mixture of the biogas energy process. We can see that the methane has 82% of the total mixture, then carbon dioxide with 14%, next other gases such as nitrous oxide with 3.6%, and finally hydrogen sulfide with only 0.4%. Then, according to the following graph, we can see that the methane particles can react faster than the CO2 particles in high quantities at a certain temperature inside the aerobic process of the biogas energy process. We can see how the methane particles has more reaction mode than the CO2 particles with a certain concentration and at a certain elapsed time in minutes. Then we can see how the CO2 particles has more regeneration mode than the methane particles. Let's remember that the reaction mode is the most important characteristic or factor into the aerobic process for the transformation into biogas energy in the whole biogas energy process. The following table shows the considerable pressure that the biodigester have to apply to the gases. Also compare the literature data obtained to the real data that the experiment showed. There are only two elements, pure methane particles and pure carbon dioxide particles. Next, the following graph shows that in comparison to other gases, methane has more absorption than the other ones inside the biogas energy process. We can see only three elements, methane, ethane, and propane. Methane has more absorption at a certain pressure than the other ones. The following graph shows the correct temperature and pressure at which the pure methane particles can have more possibilities to be transformed by the microbes into biogas inside the biogas energy process. The following graph shows the transformation of methane particles into biogas energy according to the methane percentage inside the complete process of biogas generation, taking into consideration the time it takes to be absorbed.
In the hypothesis 3, regarding of the following graph, it is safe to mention that Apodaca would be an optimal location to carry out the capture and transformation of the particles into biogas energy in order to reduce methane. A low food waste is observed in both areas, operational and potential, so that the efficiency with the animals will increase, reaching a considerable level of methane to the capture. On the other hand, we have to consider the landfill gases that we consider few for what would be expected as it is the main factor of methane production, but that is where the livestock waste that are usually dead animals or part of the production that I don't take advantage. This in turn produces a certain part of landfill gases which neutralizes the lack of them in this location. As a final fact, we have the treatment of water waste that is crucial to identify the ways of generating clean energy, something that is also sought to be selected by separating methane with the plastic membrane.
Based on the results obtained, we must highlight the great advantage that the SBN zeolite acquires by having the ability to have a very high absorption with respect from methane. The process of recollection and transformation of methane into biogas energy have a certain cost. Nevertheless, according to Jackson, it could yield greater climate and economic value because of methane's greater potency as a greenhouse gas. Focusing on the point of absorption, components external to CO2 are identified, but equally favorable for the material from which the plastic membrane is made. Adding the fact that pure methane will be obtained in all cases, but the same membrane efficiency. Knowing that the SBN zeolite attracts the methane particles thanks to the process of absorption gases in membranes and turn them into pure methane. Then the amounts of gas attracted by the plasmatic membranes will be used for the production of biogas, processing them in the biogenerator or biodigester, and creating this alternative source of energy. This process can occur because of the anaerobic fermentation that is carried out inside the biodigester that separates the important components and the residues to form fertilizer and the biogas energy. Also, this biogas will serve us as an alternative source of energy that, besides that, helps to the environment by decreasing the emissions of methane to the atmosphere. So, if the emission of methane gas will be reduced, then the levels of this gas will decrease gradually. Jackson says that while methane removal makes the most sense as an early tool, it could also play a role in the long term as well by cleaning up the methane emissions we ultimately can't or opt not to eliminate.
We can conclude this research by mentioning that all our hypotheses were correct, since after the investigation process we could verify the truth of this, thus obtaining the efficiency of the use of methane as a source of energy through biodigesters, but the determining factor resulting from the investigation was the effectiveness of the zeolite plastic membrane. On the other hand, it's important to highlight the use that could be given in the livestock sector of Apodaca and the possible expansions, obtain a cleaner and more likely entity to recover from the high emissions recorded in recent years, but all this while taking advantage of the same solution, using this method in turn as a renewable energy.